Have you ever wondered how an animal could survive carrying two 20-centimeter daggers in its mouth without starving or breaking its teeth during its very first hunt? We grew up thinking the saber-toothed tiger was simply an angry cat from the Ice Age, but the truth is that this popular image hides a much stranger and more complex biology. The famous Smilodon was not a modern tiger with a few extra accessories, and understanding this brutal difference is the key to discovering why it dominated the Americas and then disappeared from the map. The Smilodon is the ultimate icon of Pleistocene megafauna, but its success came from far more than the terrifying size of its upper canines. These enormous teeth were precision tools, requiring an entire ecosystem filled with giant mammals to justify such extreme evolutionary specialization. If you think bigger teeth mean a stronger bite, get ready to have your perception of predators completely turned upside down. Fossils show that it coexisted with other formidable carnivores, but none had anatomy so radically adapted to killing prey that could be many times its own size. This animal's survival depended on a rare combination of brute strength in its forelimbs and a killing technique that avoided contact between its teeth and bone. It is this apparent fragility of the sabers that makes Smilodon a far more fascinating biomechanical mystery than any movie monster. Many people confuse the genus Smilodon with modern tigers, but they belong to completely different lineages within the saber-toothed cats. This taxonomic distinction is crucial because it explains why the fossil evidence points to behaviors and habitats so different from those of today's big cats. By separating myth from science, we can begin to understand how this unique predator was shaped by, the harsh environment of the Ice Age. The Smilodon ruled during the Pleistocene, surviving until the end of the last Ice Age, roughly 10,000 years ago. Its fossils are abundant throughout the Americas, especially at the La Brea tar pits, which preserve thousands of individuals in remarkable detail. This geographic distribution proves that it was not a rare animal, but a central and highly successful member of continental megafauna for millions of years. It lived in environments ranging from open grasslands to dense forests, demonstrating an ecological adaptability that challenges the idea that it was an extremely specialized predator. Unlike modern predators restricted to specific niches, Smilodon adjusted its hunting strategy according to vegetation and the availability of local prey. This flexibility was essential for coexisting with other large mammals in ecosystems that changed dramatically with the climatic shifts of the Ice Age. It lived alongside giant bison, extinct camelids, and enormous ground sloths, forming a complex and interdependent food web. The presence of these massive herbivores was not simply a source of food, it was the very reason its specialized teeth and musculature evolved in the first place. Without this diverse megafauna, Smilodon would have been a biological mistake. With it, it became the apex predator of a lost world. Smilodon was a biological tank, with massive forelimbs adapted to pin down prey much larger than itself. Its robust build contrasted dramatically with the agile silhouette of modern tigers, revealing an evolutionary strategy focused on explosive power rather than speed. This body structure indicates that it relied on short ambushes and brutal physical control, never on prolonged chases across open terrain. Despite its popular nickname, it belonged to the subfamily Machaerodontidae, completely separate from the Pantherini, which includes modern lions and tigers. This taxonomic distinction explains why its proportions, skull, and even jaw articulation were so radically different from those of living cats. Calling it a tiger is a conceptual mistake that distorts our understanding of how natural selection shaped specialized predators during the Ice Age. There were at least 3 distinct species of Smilodon, ranging from smaller forms to the colossal S. populator of South America. Each species displayed subtle adaptations to its particular ecosystem, showing that the genus was not a single uniform animal, but a diverse and resilient lineage. This morphological variation within the genus reinforces the idea that its evolutionary success came from adaptability, not simply from its famous saber teeth. The upper canines of Smilodon could reach 20 centimeters in length, yet they were surprisingly fragile from side to side and prone to fractures if used incorrectly. This apparent contradiction between enormous size and fragility reveals that they were not impact weapons, but precision cutting tools designed to be used only on soft tissue. Evolution prioritized length over strength because its killing technique depended on avoiding contact with bone, not on brute force in its bite. Its jaws had an exceptionally wide gape of up to 120 degrees, allowing the sabers to penetrate deeply without colliding with the lower teeth. Extremely powerful neck muscles compensated for the relatively weak bite, transferring the force of its entire body into the final strike. This shows that the teeth were only the visible tip of an integrated system of skull, neck, and forelimbs working together in deadly synchronization. Unlike modern cats that suffocate prey with prolonged bites, Smilodon likely used its sabers to cause massive, rapid blood loss. This strategy minimized the duration of the struggle and reduced the risk of breaking its precious weapons against prey that was still alive and fighting back. The extreme specialization of these teeth was a high-risk evolutionary gamble, brilliant when it worked, but catastrophic if the ecosystem changed. The Smilodon fed almost exclusively on large megafaunal mammals, such as giant bison, camelids, and young mastodons. These colossal prey animals were the only energy source capable of supporting its high metabolism and highly specialized anatomy. Without large-bodied herbivores, its saber teeth and powerful muscles would have been an unsustainable evolutionary cost in any ecosystem. Isotope analyses of fossil evidence confirm that it preferred large-bodied prey, avoiding animals with armor or excessively thick skin. This reveals surprising dietary selectivity for an apex predator, showing that brute strength could not replace a refined nutritional strategy. The seasonal availability of these herbivores shaped its reproductive and territorial cycles far more than the simple presence of meat. Hunting animals this large involved constant lethal risks, from fatal kicks to fractured teeth during uneven struggles. Every successful meal was a statistical victory against incredibly high odds of severe injury or premature death. This high-risk, high-reward relationship explains why Smilodon depended so heavily on perfectly executed ambushes and absolute physical control. The most widely accepted hypothesis is that Smilodon used short ambushes, taking advantage of dense vegetation to approach its prey without being detected. Its massive forelimbs would pin the prey to the ground before the teeth even came into play, preventing prolonged chases. This grab first, bite later strategy was essential for protecting its fragile sabers from sideways impacts during the struggle. The fatal strike was probably a precise bite to the throat or abdomen, causing massive blood loss within seconds. Unlike lions, which suffocate prey with prolonged bites, Smilodon minimized contact time to reduce the risk of fracturing its teeth. Every movement was calculated, brute strength in the arms, surgical precision in the teeth, all orchestrated within deadly fractions of a second. It's crucial to remember that this is a reconstruction based on biomechanics, tooth marks found on fossils, and comparisons with living predators. We don't have videos from the Ice Age, but the fossil evidence consistently points toward this model of ambush hunting and physical control. Accepting this scientific limitation doesn't weaken the story, on the contrary, it makes Smilodon even more fascinating as an evolutionary puzzle. Fossil evidence from La Brea shows remarkably high rates of healed fractures in adult Smilodons, suggesting that they survived serious injuries for long periods. This resilience is difficult to explain for a solitary animal, because isolated predators rarely manage to feed while recovering from debilitating injuries. Some researchers interpret this as strong evidence of social care or even food sharing within cooperative groups. On the other hand, the high concentration of fossils in the tar pits may simply reflect natural traps that attracted multiple independent individuals at the same time. Comparisons with modern cats show that solitary species can also develop healed fractures if they have access to carcasses abandoned by other predators. The absence of extreme sexual dimorphism in canine size weakens the hypothesis of intense competition for harems, which is common in some social animals. The debate remains open because behavior does not fossilize directly. We only have indirect clues that are open to multiple interpretations. This uncertainty is not a failure of science, but an invitation to think critically about how we reconstruct the lives of extinct animals from fragmented bones. Whether it was solitary or social, Smilodon challenges our modern categories of feline behavior, reminding us that the Ice Age played by its own rules. Pleistocene America was a dynamic mosaic of grasslands, forests, and tundra, shaped by glacial cycles that constantly reshaped habitats. This environmental instability demanded extreme adaptability from megafauna, creating evolutionary pressures that favored specializations like those seen in Smilodon. The ecosystem was never static, it was a constantly changing stage where only the most flexible or perfectly synchronized species could survive. Alongside Smilodon, American lions, dire wolves, and short-faced bears competed for the same resources in an arena filled with formidable predators. The coexistence of multiple apex carnivores indicates that prey populations were abundant enough to support overlapping niches without immediate collapse. The presence of so many specialized predators reveals a biologically rich world, vastly different from the impoverished fauna of the Americas today. Smilodon was not an isolated evolutionary accident, but a direct product of the complex and interdependent food web of the Ice Age. Its anatomy, behavior, and geographic distribution only makes sense when understood as responses to this specific ecosystem, a world that no longer exists. Understanding its world means understanding that its extinction was not an isolated event, but a symptom of a much larger systemic collapse. Smilodon disappeared roughly 10,000 years ago, coinciding with the end of the Pleistocene and the mass extinction of American megafauna. Rapid climate changes altered vegetation and prey availability, destabilizing the food base that supported specialized predators. Without herbivores large enough to justify its extreme anatomy, the energetic cost of survival became unsustainable within just a few centuries. The arrival of humans in the Americas added another layer of pressure, possibly competing for prey or directly hunting the last remaining herds. Fossil evidence shows temporal overlap between humans and Smilodon, but it does not prove direct causation in every region. It's likely that climatic and human-driven factors acted together, creating a perfect storm for species that were already vulnerable. No single cause can fully explain its extinction. It was a multifactorial collapse that hit highly specialized predators especially hard. Generalists such as wolves and cougars survived because they could switch prey and habitats when the ecosystem changed dramatically. Smilodon, trapped by its own adaptive perfection, became a victim of the evolutionary success that had defined it for millions of years. How did a predator so perfectly adapted to its environment end up disappearing just when it seemed to be at the height of its evolutionary success? Smilodon had strength, lethal teeth, and millions of years of biological refinement, but none of that mattered when the rules of the game changed. Its extinction was not a failure, but the inevitable consequence of an evolutionary gamble that worked brilliantly, until it didn't. It was a specialist in a world that ceased to exist, becoming a prisoner of its own efficiency as the ecosystem collapsed around it. Generalists survived because they could improvise. Smilodon had no plan B, only a plan A executed with deadly perfection. This reveals an uncomfortable truth. In nature, extreme adaptation can be both a superpower and a conditional death sentence. The real mystery isn't why it disappeared, but how it managed to survive for so long while being so vulnerable to systemic change. Its story is a reminder that resilience doesn't always come from strength, but from the ability to reinvent yourself when the world turns upside down. By studying its downfall, we learn more about survival than we can from almost any modern predator still alive today. Smilodon wasn't a monster, but the perfect predator for a world that no longer exists, and its extinction is a warning about adaptation. If even the apex predator of the Ice Age disappeared when the rules changed, what does that say about our own resilience today? Comment below and tell us which lesson from this predator impacted you the most, and subscribe now so you don't miss the next mystery of the megafauna.